I want to welcome you to the National Academy of Construction's Ask Me Anything webinar for the spring 2026 semester. My name is Susan Bogus. I am an NAC member and chair of the Gerald May Department of Civil Construction and Environmental Engineering at the University of New Mexico. That's in Albuquerque, New Mexico. I'm going to be moderating this evening's session. Our theme this semester is Artificial Intelligence in the Design and Construction Industry, with a focus on the legal aspects and the practical aspects of AI in design and construction, including both challenges and opportunities. The National Academy of Construction was established in 1999 to recognize our industry leaders. An important purpose of the Academy is to share the collective knowledge and experience of our members to improve the industry. We have established the Ask Me Anything webinar series to help transfer knowledge of our members to our next generation of construction leaders, with this webinar providing a means to link past and present participants in the construction industry. Our format today is simple. Our speaker will share brief remarks, and then we'll open it up for your questions. If you haven't submitted a question yet, you can still email questions to nacama@austin.utexas.edu. And we've put this address in the chat if you want to send questions. At the end of the webinar, one student will be randomly selected to receive a $500 scholarship. Now on to our topic for tonight. Burcin Kaplanoglu is a globally recognized technology executive, AI expert, and thought leader in construction innovation. He is the founder and chief technology officer of SBK Technologies, which provides custom technology advisory services to private equity, construction, and industrial companies. He was the vice president and co-founder of Oracle Industry Lab. He pioneered the integration of artificial intelligence, robotics, Internet of Things, and digital twin technologies into real-world construction solutions. Burcin's work has transformed how the built environment adopts emerging technologies. He holds a bachelor's degree in civil engineering and a master's degree in construction management from Istanbul University and a PhD in engineering and management from the Illinois Institute of Technology. He worked in the construction industry and as an adjunct professor at Northwestern University before joining Oracle. Widely honored for his visionary impact, including recognition by Engineering News Record and the Construction Industry Institute, Burcin is shaping the future of construction with intelligence, imagination, and global reach. Welcome, Burcin, to Ask Me Anything.
Thank you. Hi, everyone. I see there are 33 people. Thanks for joining this afternoon. So I will spend a few minutes about my background. So I spent almost 17 years in construction. While I'm doing that, I actually, in the first 6 years of my career, I was working on my PhD. So I worked in the industry, actually worked on my PhD, and I had a parallel path. So one was I received my PhD, and I actually taught at Northwestern a class in the fall for almost 10 years. That's one path. The other path is I stayed in the industry and worked in many different things, from infrastructure development, real estate development, construction, and those took me the first 16 years of my career. 9 years ago, I joined Oracle, joined the software division, which provides solutions for construction engineering. The one that most people know is like Primavera scheduling and ACANX and a few other products. So I recommended that we should build a lab, and the lab was not an office building, an R&D lab where we actually built a small construction site. The concept there was, why don't we go and take sensors and other parts and partner with others and physically do things, right? So you could get a concrete sensor embedded into concrete and then link it to a scheduling product, and then you test and validate, then you can actually make that commercially available. Basically, these kind of things enabled new solutions to come to market. part of that was robotics. So like integration with laser scanners, with, like robotic solutions, drones, data capture. So end up working many different fields in construction. I also work on product development for the last 2 years. And I want to say last 3 months, I actually started my own advisory firm. So what do? I advise very large contractors. They range between $4 billion to $20 billion. That's the range, revenue, very large. And I'm providing advisory on AI and robotics strategy and implementation technology choices that they make. Meanwhile, I also advise some technology companies, and mentioned earlier, I'm actually having discussions to support some of the private equity work. Because if you think about the cycle, they're the ones who actually fund these projects, right? That's where the money is coming from. And then technology is providing it, and the builders are building it. I have a very large group of followers, as you see here on LinkedIn. So I post videos about technology, AI, and what's happening in this space. So if you send me a request, I'll accept, and you will be able to see the kind of stuff that I'm working on. So I'm excited for the questions. Enough about my background. I'm excited to hear what you are thinking, and let's get it started.
All right. Great. Okay, we're going to start with your questions. And please remember, you can still email questions to the email address in the chat as we go along. So to start, I have a question here from Kevin, and he's asking, which areas of construction engineering, such as scheduling, estimating, or site management, do you believe will be most impacted by AI first? And how can students best prepare to adapt to that change?
So 3 things: estimating, scheduling, site management. Today, let's talk about today. It's estimating. Why? Because now we have technology, which is pretty reliable, which can actually read documentation, find information, and help you with takeoffs, right? So there are a good number of companies who are actually today using these estimating tools, which it's a combination. Some of them is computer vision, recognizing things. Some of them is machine learning, deep learning, which are pretty mature technologies. Then comes scheduling. There are products out there which are trying to make simulations or predictions, right? They're also a lot of them are based on machine learning and deep learning. And then site. The reason I put the site at the end, by the way, I spent a lot on site and actually robotics, is I believe that's the biggest impact we're going to have, but it's not going to happen tomorrow, right? So it is happening. So there are examples of this. Like you can actually get a $300 360 camera, walk a site, capture the information. Humans can walk, even you can attach to a hard hat and walk, and then computer vision can actually recognize things, and you can use it for progress reporting. That is already being done, right? So it is actually, if you look at the market, these technologies are actually pretty widely used. The same thing with drones. Drone data capture, collecting information is pretty widely used in construction engineering. At some point, I read this study, this was I think 4 years ago, almost 50% of the licenses that people got to able to fly drones was actually engineering and construction and real estate. Because we need to capture things from outside. We need to capture buildings like the picture behind Susan. If you want to capture that, you want to build a model, you definitely need these technologies. So the order today, I believe, is estimating, then scheduling, then field. And the field's complexity also comes from our work environment constantly change. And it requires, especially if we're going to introduce robotics, it requires agility, it requires understanding of the space, it requires world models. So this is a term that is widely used in the last 6 months. The model that can understand the world, can understand the physics, and can respond to it. That's what that means. So those 3, I think, are going to change, but in the order I just described.
Okay, great. Thinking this might be a reasonable follow-up, but Molana has a question that says, how do you see AI evolving to address these complex system-level coordination problems, going beyond just local optimizations?
So let's talk about the technologies. As a technologist, I want to highlight that. So what is mature today? Machine learning, deep learning, and computer vision is pretty mature. So, from your credit rating to, systems making recommendations what to buy next. Look, we have been exposed to this. The data is out there, especially the last 10 years. It's widely used, especially machine learning and deep learning. And comes computer vision, right? If you, like I live in Chicago, if you enter the US, I have global entry. As soon as I enter, I don't even, pick up my passport, recognizes me, I walk in, right? So by the way, I saw this 8 years ago in Australia, first time. I went for work, I walked in, he recognized me, I entered, I didn't talk to a single person. And vision improved a lot. So a lot of vision models typically have issues with, they can improve them up to 90%, and that last 10% is the most challenging one, and that's why we're not seeing fully autonomous vehicles at all, fully functioning everywhere, because those edge use cases are difficult to do. Now, going into next phase, I want to describe 3 other technologies that tie to it. So Gen AI. It works in some ways and it doesn't work in other ways, right? It still hallucinates, right? So it can come up with stuff. It is designed to agree with you. So if you have conversations, if you ask questions, it improved significantly, no doubt. Even like every 3 months, the math was a major issue. It got a lot better. Still can make mistakes, but it's there. And then multimodal AI. What that means is multiple modalities. Like, you can take a video of a machine. This is now being used. You can take a video of a machine working. It's making some sound and the machine is in the video. Multimodal AI can recognize what type of machine it is. And it can hear the sound, it will analyze it, and it will actually try to figure out what the issue with that machine is. By the way, that's what mechanics do. If you think about it, like, this is what humans do. When your car is making sound, you're trying to figure this out. That's what when they look at the machine, the mechanic knows also what kind of it is, what part it is. They are aware of it. So multimodal actually pretty reliably can do this today. Now, it's as good as the training model, so that's an issue. The one that's probably the most promising is agentic AI. Now, I mentioned this to Susan before the start. How well does that work? So I'll say this. Studies show, they try to measure how agents work, and I'll explain what agents are. Agents they have certain tasks. You tell them, these are the things I want to achieve. It uses reasoning. It builds, let me say this. You give a goal. Goal is, go build this for me. Then it starts making a plan. Actually, this is not new. It's been researched for over 20 years, so it's not new. The reason why it improved so much in the last 2 years is because of large language models. Because models actually allow it to understand the context. Like 2 years ago, I actually used an agent, and I said, hey, build me a 2-story, 100-car sustainable parking garage. That's it. It started asking me questions. First, it started doing research. It said, ask me the location. I gave the lat and log. It started asking me questions. Then it went and started doing research. It went online and tried to find what sustainable materials mean. When it tried to figure out zoning, that didn't work. As most of you might know, zoning data is not easily accessible, right? This is 2 years ago. After a while, after 3 minutes, it basically stopped working, right? This is 2 years ago. Now, what's happening is reliability of these systems. So when people do research, they say things like, agents can work. So this is recent, as of a month ago. The research shows the best agents can work up to 6 hours. What does that mean? Well, they work up to 6 hours with 80% reliability. So you're an engineer. Do you think that's acceptable? It's not, right? You can't be 80% reliable. You can't constantly ask human supervision. And what reliability is almost 100% when it works around 2.5 minutes of human tasks. Also, that's debatable too. What is a human task of 2.5 minutes? I'm not going to get in there. That's another rabbit hole. But research has to do some measurements. So they're trying to say some baselines. What's interesting is they found out that it doubled its time of 100% reliability. It doubled the time every 7 months. So if it's 2.5 minutes now, 7 months from now, it will be 5 minutes. And you keep adding this up, you're going to see that in a couple years' time, this will be able to perform a couple hours of work without human supervision, right? That's when things will change. Because if you can outsource some of these things, look, I am sure you all, watch TikTok videos, Instagram, other things people talk about. Oh, I just bought this, Apple little computer and I'm using OpenClaw. I have the agent to do these things for me. Yeah, you can do it. By the way, it's really not secure. I would not recommend that. But people are doing it, right? So they're having it to pay their bills. They're having to do other things. It's open source. So, your information is kept in the box. But reliability is a major issue. So going to the beginning part of the question, what is the one that I believe is really going to change how we do projects or engineering is agents. Because that when the day comes, they're reliable. They can perform a couple hours of work without human supervision. That is going to change how we work as engineers. That's going to change how companies employ and what machines can do into your day-to-day life.
So two people sort of asked a similar question, and maybe it ties in with this thing with agents, but it has to do with, so this is Sion and both Tyler kind of has similar questions in terms of how accurate is AI in interpreting drawings, like construction drawings, and maybe to be used in like takeoffs or other interpretations. Is this a potential example?
I'm gonna give the vague answer. It depends. Okay, I don't think you can find anywhere that anyone can claim they're 100% accurate. Also, when you ask people who spend time in this research, they're gonna say it depends. It depends on how old the drawings are. It depends on if the annotations are in the current training model or not. Some claim they can be 80-90% takeoffs just done with vision, and some claim they are lucky if they get 40-50% accurate, right? Like, it's kind of all over the place. It is not at a level where I will say, hey, just provide drawings from 10 years ago or 20 years ago. And some projects are, like drawings from blueprints, it's like 100 years old, right? Like, it's not there to the level where we could reliably say it will be able to do that. Now, don't get me wrong, there's tons of research done in this field. Academics are doing it. There's probably thousands probably of construction startups today who are trying to use these generalized technologies. They are bringing some data sets, whether it's data sets they own for different reasons, or they partner with other companies and convince them to give their data sets. And they are specifically training the models to do that. Again, the result is as good as the data set is trained, right? That brings up another issue. This is a massive debate going for almost 20 years. Who owns that data? Now, you can't answer me, so I can't really see your reaction. But if you ask this question in the industry and say, you build projects, who owns the data? The contractors will say that's my data. But when you actually really start having honest conversations, it's not their data. The methodology they use is theirs. Contractually, everything generated to produce that project belongs to the owner. That's how it's written. How they did is theirs, IP, but what's in the data about what that project took is owned by the owners. So that's a big debate going on now. Like, who owns the data? How can you extract it? And then comes the other thing. All this stuff is siloed, different systems. I don't think construction has a problem of not having enough data. Construction has a problem of having data being spread out everywhere and really figuring out who owns it and who will be able to use it. Because the reality is, if you really want to train these things properly, you need to have a lot of data that today is not accessible by any entity or any company or anywhere. It just requires a lot. Just think this way. To get the large language models to the level it is, they have been getting the data out from the internet like years and years, right? And if you look at just one individual company, even the biggest ones, that's not enough. And that brings another topic. So if you ever look at ENR 500, top 500 contractors in US, you're going to see a range between 40, 50 million revenue to $20 billion, right? There's a lot of companies who go up to 500 million. There's another group from 500 to $2 billion. And then there's some above, and then, it gets less and less. The reality is, I've done this, by the way, 20 years ago, and I have this exercise to do every 4 or 5 years. I go to ENR, I look at the list every 4 or 5 years, I add their revenues. It's not that significant compared to the market. Why? It's not like manufacturing, or to be specific, let me tell you this, like automotive. So today, if you look at automotive industry, it's really owned by 5 companies. And if one of them decides to make a change on their supply chain, how they operate, how they collect data, they can influence the whole market. In construction, these 500 companies are never going to agree on giving each other their data. Let's say they do it. Even that is not significant enough. Our market in US is over $1 trillion. And these 500, I believe, makes around 20% of that. So this brings other industry issues that we have. Not only we have our own silos, but our scale is very big. And even in that, if you decide to do something, it might not be big enough. I'll give you from my personal experience. I worked for a very large developer real estate company for 17 years. And at some point, we were the largest residential builder in the United States. And we thought, wow, we buy so much drywall. We should go and talk to the drywall manufacturers and see what we can do. This story is 15 years old, just to give you an idea, right? So we had this idea that, oh yeah, we're really big, we can collect this, we do this. The truth is, when people went and had these conversations, they realized how small they are in the whole market. Even though you might be the number one in the market, but because it's so separated, it is very hard to actually have that consolidation. Why am I telling this? Because if you want to have a good system, a system that actually can do good takeoffs, like reading drawings and all that, I think today is less of a technology issue. It's more about training that technology to deliver the results you want. Whoever can figure out how to get all that data and train these things is going to be ahead of the market, but no one has figured it out yet.
I mean, that's great. It got me thinking. I talk a lot to our local industry here about AI, and most of them have, AI that they use, but just on their internal data, right? They're not sharing their data, nor are they pulling in from the outside. So I think that ties into a question here we have, and it's related to when this is from NADA. When companies try to adopt new technologies like AI or digital twins, what are the biggest challenges they usually face when they're trying to apply these to real projects? And how could young professionals help them to overcome these?
Great question. So again, look, AI is a massive umbrella. I think people respond to technologies in that umbrella differently. So I'm going to go back to 5 technologies I mentioned. If it's machine learning, deep learning, or computer vision, people are actually pretty used to it. Like people are used to taking pictures and things are being recognized. I think they're pretty mature. People rely on them, and adoption hasn't really been the issue. The part that I definitely see, I call this passive resistance, is when it comes to the generative technologies. Why? Because the messaging in the market, you can read it every day, every news last 3 years, is we're going to develop this technology. You're not going to rely on humans as much. It's going to be this is fully automated. It's going to have intelligence. It's going to do these things, right? Let's say you are rolling a technology out today in a company and people heard that, right? This is like they've been hearing it for a couple of years. And they also watch a lot of sci-fi. So like if there's actually studies show the negative sentiment of the word AI, in the US is actually pretty high. It's even higher than Europe. In other parts of the world, like Asia and Africa, it's actually a lot more positively perceived. And the reason recent research shows is in those parts of the world, they believe that they don't have enough resources and AI is going to help them become more efficient and they'll be more, like, they'll be able to generate more money, revenue, they'll be wealthier, right? That's the perception. In our world, the perception is this is going to take over my job. What am I going to do when it happens, right? So the long-winded answer, I'll say it's the humans. I think we really need to address the fact that it's been messaged to the world that this is going to take over, it's going to take over your job. You can say all day long, well, it's going to give your sanity back, you can work, less hours because you automate some of the stuff, it's going to do this. It is, people still think about this. Like people think about, okay, if I'm using these tools, am I training the tool to learn how I do it? Eventually, is this going to take over, right? I think that question is there, definitely. And I also think there's passive resistance to that. Now, let's talk about young engineers. Susan and I actually had this conversation right before this started. One of the gaps that I am very concerned about is what happens when you graduate college. Look, a great example is computer programmers. In the hierarchy of computer science, right? They are the ones who do the repetitive things. They do the testing. Like basically the stuff they do is really valuable, but it's the stuff that is very repetitive. And then what happens? Today, there are tools which can do a fairly good job. It still needs supervision. It's not perfect, but it does a fairly good job. And there's been big drop on not just college hires in that field, but also employment. It had over 10% impact the last couple of years. Why? They're automating itself. And if you think about it, it's a little actually interesting that it's the technology that is developing is eating its employment, right? If you think about it, it's the same thing that's actually impacting itself first. For engineers, I was just telling Susan before we started that, look, I was in an office. I then would go every day to the site. I was around these 5 engineers. We would have conversations. I'll hear their conversations. I was the junior guy. This is 25 years ago. I did different things than they did, but I would learn from those conversations, right? I'm around it. They hired me. Trust me, I did this repetitive stuff that was super boring, okay? I had to receive, and still this happens today, 25 years later, I had to receive paper drawings. I had to record them into a system. I had to have the engineers review it. I would review the ones we had to stamp them, and I had to take them, roll them, and send it to the mailroom, okay? At some point, my innovation was I digitized it, I put them on CDs, and that was like the big thing in the company. This is 25 years ago, right? And if you look at that, I learned so much by being around those people. I learned so much by being influenced. I would hear them argue with contractors, and that's what happened. Like it's life. Like you learn by being around it. And then I'm going to give you another example in education. So I learned critical path method of scheduling by doing by hand, paper, pen. And God, I was in college 30 years ago. So when I was in college 30 years ago, it's a big number, but 30 years, but I would ask the question, why am I doing this by hand? I know how to use Primavera. I can do the schedule. I know how to build the logic. I can link these things. Well, the answer was, well, you need to do this by hand. You need to prove us you can do by hand. So when you use the tool, if there is an issue with the logic, you'll be able to identify it quickly because you actually did this by hand. Like certain things won't make sense to you because you were able to do this by hand so many times, you will have an idea. Now I'm going to give you the counter argument to you guys. And Susan, if I need to stop, let me know because this is a very long-winded answer. The other counter argument to that is there's a lot of things that we don't need in our lives, right? Like I only know 3 phone numbers, my wife and my 2 kids, right? That's all I know in my memory. I don't need to know everyone's phone number. I don't need to keep that. That really gives that, mental space back to me. Meanwhile, if I'm driving, I heavily rely on Google Maps. Why I need to go someplace, it helps me for directions. I've always been terrible at directions. So you know what this does? It kind of level sets me with other people, right? I'm going to end it with one other example. I think this technology works really well and it's going to really help the industry. We'll be able to do more with, we'll be able to perform a lot more efficiently when it's really taking over repetitive things. The risk becomes when it's actually taking things that requires, I wouldn't say full intelligence, but some sort of intelligence. The best example, I read this a couple months ago somewhere. I'm not going to take the credit. I love the example. The best example is cab drivers in London. So if you've ever been to London, these cab drivers have to spend 6 to 9 months to learn every street, and then they take a test. So this has been done for a long time. They know every street. They need to take this test, and everyone talks about it. There were research done on the cab drivers, how their memory works, because they had to remember all these streets and how they memorize. Well, you know what? You now have technology with GIS and everything else. You don't need to know that. You just have to put the address and it takes you to that location, right? So it is taking something away, and then now you can have Uber and Lyft drivers perform the same task. So something that was a very hard entry, right? It was a difficult job to enter. All of a sudden becomes not that difficult to enter because you're actually using something to leverage. So going back to engineering, I think if things automate on things that makes us human, that is when the things will start getting a little difficult, right? But if it is helping engineers to automate some of these things that we don't really want to spend the time, no, that's good. And I can actually finish my job much faster. I can go home and spend time with my family. So there's a lot of benefits to it. I gave a very long answer.
No, and just on a side, we do still teach scheduling. We expect our students to be able to do a forward pass and a backward pass by hand still, but for that same reason, right? To really be able to understand and review other work. So you talked about students, how good it is, for getting that on-the-job experience and stuff. But here's several students had questions. Here's one from Lucky that says, how can young professionals entering the industry prepare themselves to responsibly use AI tools while protecting both their companies and their professional licenses?
Well, that's a great question. So let me think for a second. So I think as you're entering into the workforce, I have I'm going to share 2 things that I think you should start doing. One is you need to spend time with the tools, right? Look, your generation already grew up with the tech. You need to spend time and understand what it can do for you. That's one. The other thing needs to be understood, and I don't know at this stage if universities actually are doing that. Everybody has to understand how it works and what the limitations are. Because once you understand how it works, what the limitations are, then you'll be able to use it efficiently. Let me give you an example. A couple of weeks ago, I was asked to do a white paper. and about a topic, I had to do research, right? So what did I do? I could have spent days doing research online. I went to Gemini, I have a paid subscription, I did deep search, I gave the topic, I gave what I'm looking for. It took maybe 5 minutes, it did research, it gave me what I'm looking for. Now, because I know the limitations, I know it can hallucinate, I know it can make things up, and I'm not going to like copy paste that, right? What I did is, it's telling me things, I'm reading them, and then I'm seeing the reference, and some stuff it mentions but doesn't put a reference. I ask the references, and then I click and go to those references and I read them. I educated myself. By the way, the report, I wrote the report, right? If you put into something to say, is this written by AI? The answer is no. I wrote it, but I used the research it did to validate the things it found, and some were not accurate. Like it will say something to me, it puts a reference, you go to the reference, you read the whole thing, and there's nothing mentioned about that in the reference. I have no idea why it's referencing that, right? There's nothing. So what I have learned, because I know the limitations, I did this. So I'm going to tell you what the benefit is, right? If I did this without using this tool, it probably will take me 2 days, right? It took me 3-4 hours to do this. It didn't take me 2 days. It took me longer because it's not at the maturity level. Well, I can just copy paste and say, here's the outcome, right? It also required me to make some judgment on the findings that it did. I had to interpret. I'm sure like you could have taken, if it was 100% accurate, you could have taken it, you could have like formatted, you could have put your own little bit of words to it. Maybe you need to spend another 30 minutes to an hour, and that's it. You'll be done with that, right? It's not there yet. But then I didn't spend 2 days. I spent maybe 4 hours. I still wrote it myself. Actually, it's not true. Eventually, I ended up spending, I probably spent 5-6 hours. So it ended up being almost a day worth of work. Something would have taken me 2 days. Why? Because I am reading it. So think this way. We are not like a machine, right? So I'm reading these references, then I'm writing something, and I'm going having lunch, and I'm thinking about something, coming back, and I'm like, oh, that's maybe, how about this? How about I explain it this way? So like there is a iterative process humans do, right? You don't just take the first time you write something and say, this is it. That's not how we work. We need to like process these things in our head and come to conclusions. So that's why it took that much time, because I had to process what I read. I had to think about it. I then actually had to put it together. So this is an example of how it will help you. You just have to learn the limitations. Mm-hmm. I'll give another example. I was going to have a meeting with someone I never met before. I wanted to try this. So what I did was I took that person's LinkedIn profile and I put it in one of these tools and say, this is the person I'm going to meet. By the way, the question had privacy. So what I do is typically, like I don't give details of when the meeting is, all the stuff. Also, like if it's company information, I don't put any of that. So I am very careful on what I give to these systems. Believe it or not, some of them actually, even if you pay, they do not allow you to opt out of data protection. So even there's some paid ones, you don't have an option to say, do not train the model with this information. So here's what I did. I was going to meet this person. I said, hey, I'm going to meet this person. Here's their profile. Here's a podcast they did. And here's my profile. Give me 5 ideas of things I could provide. So give me 5. 2 were things I already had the idea. The other 2 had nothing to do with it, so it didn't make sense. But it gave a third one that I said to myself, why didn't I think about this before? So what am I using it for? I'm using it for ideation, right? I'm not going to use it for writing massive reports, as an example I've given you, right? I'm using for research. I'm using for bouncing ideas. And when I'm bouncing ideas, I also take sometimes one of these tools. Like you ask questions and keeps asking questions and it builds I'm sure most of you have tried this. You can't respond to me, so I'm assuming this. Well, another method I use is I take those, then I go to another system and put them and say, challenge this. That's all I say. Challenge this. It gives me other ideas. Then I go through that and I go to the other one. So I think saying that's my coworker sounds a little weird, but it is a sounding board for me. How about that? I think that's probably a better way of describing it. There's a machine with lots of information, and it's based on patterns. The rest of the tool, and if any of you have read about this or tried it, it is designed to agree with you. So you actually have to be very specific. You need to say, challenge this. You need to say, counter arguments. You need to ask it to do this, because it's totally like if you say, hey, here's what I'm thinking, what it's designed to say, this is the best idea in the world. Because what their research is trying in the R&D space is especially last 6 months, they're trying to have these models to say, I don't know. Because of the architecture of them, they're not capable of doing that. There's a reward system. I'm getting a little bit deeper here. There's a reward system, right? So if you get the correct answer, it's rewarded, and it's all driven by that reward system. Also, it has reinforced learning by human. What I mean by that is it gives answers, and then there's in the training phase, there's humans, thousands of humans who actually look at those and say, I like this answer, I don't like that. This is better, that's that, right? So it is designed by architecture to agree with you. And it's also designed to complement you, right? So in a way, it kind of becomes this friend always says yes to you. Now, there is another argument happening in the R&D space. Should you have some of these bots which are very skeptical, right? Can you design them to be skeptical? Can you design them to challenge how you're thinking? Or do you need some of these, like, are we going to have one day some of them we know, oh, this is the one that, like I'm having a bad day, I'll just have a conversation with this one and it's going to give me, just tell me how awesome I am and have me feel good about myself. And then other times, well, I really need to get this done and I need something to challenge what I'm doing. Is this right? Is it not right? I'm really questioning myself, and you go talk to something else. There is a lot of research done in this field. So it's going beyond to these days computer science. There are people in social studies. There's lots of psychology papers looking at how does this affect and what the results are. Yeah.
Wow, I'm learning so much. Okay, here's a question from Mohammed. So this is kind of a career question. So for students and emerging professionals who want to follow a path similar to yours, what specific skills or experiences do you wish more candidates had? And what would you tell us to prioritize for now?
Great. Okay. So if somebody wants to do a similar path as I am, which the path is I did almost 2 decades of industry experience, and then I then moved to technology, right? I also had a parallel path of, I'll say, academia to a limitation. Let's put it that way. Being an adjunct teaching one class is not a full tenured role, right? So it's similar to that. I would say being in the industry gives you a lot of credibility and understanding when you're really trying to deploy technology. But that's definitely true. You will meet people who built construction products, technologies, like all day long. I met thousands of them. It doesn't take more than 3 minutes to figure out they actually understand construction or not. 3 to 5 minutes. Because if you work in the field, you experience things, you get to see it, you see dysfunction, you learn things. I guess my advice is, if somebody wants to follow, you still have to start from actually doing the work. And then you can build on top of that to make a career change and move into technology. That will be my advice. Because when I have a conversation with someone from the industry, they know within 5 minutes if I actually have done it or not. Literally, it doesn't take much time. And that credibility is a different weight when you're having conversations, when you're trying to do new things. So I would say, start with that. If you start with technology, nothing wrong with that. you're always going to rely on other people to tell you how certain things are done. At some point, let me give you my personal career experience. I built a R&D facility for Oracle, and then we expanded the scope. So we had manufacturing, we had energy, we actually had public safety, we acquired cars and put sensors on them. It was fascinating for me. Why? I don't know these industries. I did this for 5 years. I get to meet all these experts. I got to meet the tech people. I get to meet the industry people. I asked them lots of questions. I could also see the patterns of like, okay, this industry is doing this way, then that's doing that way. But the reality is, I know that I was never going to be part of that industry, right? Because I never actually did have that experience. And every time there was a little like, it's like the computer vision. Every time there was a little edge use case or something that I didn't understand, I still had to go find the expert to ask the question who actually spent 10, 15 years in that industry in the field or whatever the work was, because there's always that gap. I hope this answered the question.
I think that's great. Absolutely. I think I'm going to wrap up with a big open-ended question here. And this is Hoda's question. And it's, how do you see AI reshaping the design and construction industry over the next 5, 10, 15, 20 years?
First, we need to stop charging by time, because these things are going to automate a lot of things. And certain fields in engineering and construction is by time. Like architects, they charge by time. There are like lawyers who do construction law, charge by time. It is going to force us to move from time-based to value-based pricing. And this is true for builders too. You know, like the model is going to change. It's no longer going to be, oh, I have 50 people working on this project, right? You are going to automate a lot of things. You're going to have a lot less humans, but that doesn't mean the value you bring is gone, right? So you're still bringing the same value, but less. That's one. The second one, I would say, so there will be companies which have a lot less employees and will be able to compete with larger firms. That's another dynamic, right? Because a lot of it is going to rely on keeping the experts and let them orchestrate. This is, by the way, this is the pitch you're hearing in the market, right? I think it's going to affect us too. And the third one I want to say, we're actually fortunate. The impact when the technology gets to that level they're talking about, and it's not there yet, the impact to us is going to be a much longer than other industries. I can give you all the reasons why. So we'll be watching what's happening there. Like we'll be watching what's happening in legal. We'll be watching what happens in finance. We'll be watching why our world is very physical, right? We still require humans to do certain tasks. It's physical. Yes, there's massive improvements in robotics. And, you know, I have seen so much improvement, especially in the last 12 months. And I believe it's going to improve. But still, we have this advantage that as other industries change, they're going to be changing way faster than we are. And we are going to, that's, I think, is our luck. We are going to watch this. And I'm hoping that we will be able to adjust education. We'll be able to adjust how we operate. We'll be able to adjust ourselves, because the impact is not going to be as quickly as other industries is going to be. I mean, there's many reasons why it is, right? I can give you a laundry list of reasons. That will take another 30 minutes. But I really truly believe, that's my third prediction, is it is going to impact us, but it's not going to be as fast as like finance or legal services or all those things which rely on human intelligence, but less physicality, more, desktop work and things you do, or like sales. It's already happening, by the way. Now, I'm going to end it with a positive story. And there's nothing to do with construction. So there are two case studies published about this. And the last one was last year. So IKEA, 3 years ago, decides that I have a call center. I get these calls. People call them. I know what the problems are. I don't remember the numbers. I think a couple thousand employees they have who's in these call centers, answer questions. By the way, think about this. It's a thankless job, right? Who wants to be on a call center? Why do people call you? They're not going to call you to say your product is amazing. They're going to call you to complain about it. There's something missed, shipment isn't there, the product doesn't work, you can't connect the pieces together. It's not a fun job, right? You're never not actually enjoyable. So what they have decided is to take some of those, not all of them. They did not lay them off. They reskilled them, and they decided they need to convert them into design consultants. What does that mean is when you walk into a store or you're doing online shopping, they can come and advise you. They'll see and say, hey, you're trying to buy this. They can ask questions. Now, the key there is because you worked in, think about this, because you worked in call center, you know what the problems are, right? You know what is good, what's not good. They train them. So they guide the customers. But also as they're guiding the customers, they're upselling it. They'll say, well, you bought this table. Have you thought about a lamp? Oh, you're going to college. You got this. Did you get this thing? Like they are. So the results are, case study shows, the results are employee satisfaction significantly improved because they're doing work that they enjoy. Almost 70% of the questions is answered by a bot. And when things get complicated, they have humans answer, right? There's some part of it. I think 30% stays in the job and 60-70% does this job. They're happier, so the employees are happier. The company generated $1.4 billion additional revenue by this. They measured it. Why? Because they were upselling stuff people had. So it benefited the company. It benefited the employees. It has taken something that, where's my stuff? Was able to easily answered. Why is this not happening? Or you are missing a part. You ask this question. It will pull up a spec and say, here's how you attach it. You don't need to talk to a human for that, right? So this is we hear all the bad stories. Not everyone talks about the good ones. And it's really this kind of case studies are buried within the bad news because, as a society, we love to hear bad news and we get all hyped out about it and hear about it. But there is definitely good ones that are out there like this one, benefit the company, benefit the employees, and benefit the customers. So the question is, I don't know what that is for construction, but if you look at this, I'm sure there's going to be things similar to this where we can deploy.
Well, I think that's great. Gives us all something to think about and how we can search out the benefits going forward. That's all the time we have for today. I do want to announce that our scholarship winner is Anna Gauman at the University of Massachusetts Amherst. So congratulations, Anna. I also want to thank you for joining us this evening, and we look forward to seeing you at our next webinar. Thanks and have a good evening.